Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about how data scientists influence business decisions. This episode is based on a tech blog titled Meta's Data Scientist Framework for Navigating Product Strategy as Data Leaders, written by their analytics team. You can find the blog link in this episode's description. Throughout this episode, we will explore this topic from both the business and data science angles. Now, let's dive in. On the business side, let's first take a look at the problem to be solved. Meta, formerly known as Facebook, is one of the largest and most complex technology companies in the world. With billions of users across platforms like Facebook, Instagram, WhatsApp, Meta operates at a massive scale, with diverse products and a wide range of user interactions. Data is deeply central to how Meta builds and improves its products, and data scientists there are embedded directly into product teams rather than sitting in a centralized analytics silo. The core challenge that motivated this blog is this: how can data scientists go beyond analysis and become strategic partners in shaping product directions? Rather than merely reporting insights, Meta's data scientists are expected to help define strategic choices, even in situations where data is sparse or the problem itself isn't clearly defined. In a business where products evolve rapidly and data contexts can vary widely, having a clear mental framework for approaching product strategy is crucial. This challenge matters because it determines whether data science is merely reactive, which just answer questions after the fact, or proactive, help steer the product toward meaningful user value and sustainable growth. Now that we've understood the business problem to solve, let's shift gear and dive into the technical side to see how the team tackled this challenge. At the core of this tech blog is a framework that organizes data-driven product strategy into 4 scenarios, each defined by whether data availability is high or low, and whether problem clarity is broad or concrete. This creates 4 quadrants, where data scientists adjust how they contribute strategically. The first quadrant is called the pioneer. This is when you are exploring a problem space that's still vague and you don't yet have robust data. Imagine being tasked with improving advertiser value, but without solid metrics or historical behavior to rely on. In this scenario, the role of the data scientist is to think from first principles. That means working with stakeholders to define North Star metrics, which are high-level measures of success that map back to the business goal, and even if they can't be precisely computed yet. From there, data scientists build a supporting metrics framework, partner with cross-function teams to collect the minimum viable data, run lightweight experiments or observational studies, and use early insights to narrow the problem. It's a combination of creativity, structured thinking, and collaboration that gradually turns ambiguity into clarity. Now, let's move to the second quadrant, the craftsperson. Here, the problem is well defined, but there still isn't enough data to answer it directly. A real example Meta shares is privacy-preserving machine learning. In this case, the team faced a situation where much of the data used to model labels would be removed. Yet the product goal was to achieve similar prediction accuracy as if the data were still available. In scenarios like this, where expected data may be missing entirely, it becomes critical to design targeted data collection strategies and measurement systems that extract the most insight from the list data. This might involve using proxy or analogous data from similar contexts, or building lightweight analytical models to bootstrap understanding. The emphasis here is on learning milestones, clearly defined checkpoints that help reduce uncertainty step by step, rather than over-promising results too early. The next one is the explorer quadrant. In this case, you have plenty of data, but the problem space is still broad or not clearly defined. For example, when Meta was establishing its first dedicated e-commerce ad product strategy, e-commerce ads were already a $20 billion business through horizontal ads investments. However, it wasn't clear whether the product truly met the unique needs of e-commerce advertisers, or whether key opportunities were being missed. In this quadrant, data scientists lead with pattern recognition and structure creation. This includes applying techniques like segmentation or clustering to identify distinct groups within the data, conducting gap analysis to uncover underserved areas, and building opportunity sizing models to quantify whether strategic focus could have the greatest impact. Here, the data itself becomes a guide, helping transform a vague direction into concrete strategic levers. Finally, there is the optimizer. This is the classic data science sweet spot: rich data and a clearly defined problem. But even here, strategic thinking separates elite practitioners from standard analytics works. In this quadrant, the goal is to go deep into metrics, not just tracking performance, but understanding the dynamics and trade-offs between different outcomes. For example, when testing a new ads format, the team might expect the product to drive conversion improvements without sacrificing organic engagement. Data scientists can use techniques like multi-arm bandits, which is a form of adaptive experimentation, to continuously test variations and learn more efficiently. They can also build feedback loops that allow analytics to evolve as results come in, ensuring optimization stays aligned with long-term strategic goals rather than short-term metrics wins. Across all four quadrants, the block highlights an important underlying theme: adaptability and collaboration. The most effective data scientists don't just bring technical skills, they work closely with product managers, engineers, and designers to turn insights into actionable product strategies. This means speaking in business terms, co-creating metric frameworks, respecting technical constraints, and integrating qualitative and quantitative perspectives into a single, coherent narrative. The framework also provides guidance for navigating the messy reality of real-world product work, where data availability and the problem clarity are constantly changing. By understanding which quadrant they are operating in, data scientists can choose the right approach, whether that's exploratory measurement design, hypothesis testing, segmentation, or optimization, and communicate clearly with cross-function partners about what's needed next. Now, we've discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we explored how Meta's data scientists approach product strategy using a structured framework that adapts to different data and problem scenarios. We walked through the distinct analytical approaches, defined by whether data availability is high or low, and whether problem clarity is broad or concrete. Each scenario requires a different mix of thinking, collaboration, and analytics to drive meaningful product value. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.